guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at speed time graphs. So before I begin the video, please do not forget to perform an LSS, that is like, share and subscribe, and without further ado, let us begin. Right, so speed time graphs is the sort of topic that's much better understood when doing examples. So let's go and dive right into the example, and I will be explaining every part of it and how exactly to do it. So let's have a look at this first example we have. Okay, the first example says a cyclist is training for a competition and the graph shows one part of the training. Okay, good to know. Now in a speed time graph, your y-axis, that's this axis over here, the y-axis, is most likely in 99% of the cases it's going to be speed, and your x-axis, that's this axis here, is most likely to be the time in a speed time graph. Now the first thing you want to do when you have your speed time graph is make sure what unit you're working in. The speed, the unit over here, is meter per second, and the unit for time is seconds. That means it's correct, the units match. If the time unit was, say, maybe minutes, then for whatever answer we would have had for the minutes, we had to convert it to seconds, because eventually they want the speed to be in meters per second as labeled over there. So this is how a speed time graph looks like. Now in a speed time graph, when you have a straight line, in this case from here to here, this means that the object or whatever person, the person or any sort of thing that's in motion, is at constant speed. Constant speed. Please do note that this is only for speed time graphs. For distance time graphs, there will be another video coming up on that. So in a speed time graph, a straight horizontal line represents constant speed. A straight line that's not horizontal, either it's upward sloping like this one but straight, or it's downward sloping like this one as well but straight, then it's either acceleration or deceleration. If it's straight and slanted going above, like going to the top, then it's acceleration. And if it's a straight line but slanting downwards, then it's deceleration. I think that's how you spell it. Please bear if there's a spelling mistake there. Now deceleration is basically negative acceleration. Now these are the three main components that you need to know. Of course, in other cases there can be something like this. Say if the graph started from somewhere here and was going like this, it was not a straight line and it was maybe like a bending line, like it bended like this, then we say it's non-constant acceleration. Same if the deceleration was not straight and maybe it was something like this, coming down like this, then we say it's non-constant deceleration. It's always constant when it's a straight line. Whenever it's straight, it's constant. If it's not straight, then it's non-constant. Right, so let's look at the first part of the question, what it asks us to do. So the first part says calculate the acceleration during the first 10 seconds. Now to calculate acceleration in a speed time graph, all you have to do is find the gradient of the line. Now of course, when you are trying to find the gradient of the line, they will give you some sort of a limit as to say which gradient you're trying to find, because if you see the graph we have here, you can see there are three different straight lines. There's the first one that's from here to here, we have another one that's from here to here, and we have another one that's from here to here. We have three different lines. So which gradient are we trying to find? The answer to that is in the question itself. It says calculate the acceleration during the first 10 seconds. So go to your x-axis, that's the time axis, and label where 10 seconds is. This is where 10 seconds is. Draw a straight line or a broken line, however you like it, to the part where this intercepts the graph, and it intercepts right there. So basically it's telling us, or it's wanting us to find the gradient of this line. Now we know when you're trying to find the gradient, the formula you use is y2 minus y1 all over x2 minus x1. However, there is a shorter trick to do this, because in this case you are starting from the origin, meaning you're starting from the coordinate point 0, 0. So all you can do is do change in y over change in x. So basically what that means is change in y, like how further across the line is, and divided by x, how much to the right the line is. So what I mean is, all you can do is simply go here, go and trace it to the y-axis. That would be 18, and divide that by how much it goes to the x-axis, that is 10. So 18 divided by 10, and that is 1.8. That is the answer for the first part. The A part, 1.8 meters per second squared. The unit is already there, but please make sure that if the unit is not there, you include the unit from your side. All I did was I found the gradient of the straight line during the first 10 seconds, so the line from here to here. I found the gradient, and the gradient was 1.8. I did the change in y over change in x, that's 18, because it's 18 to the top, and divided by 10, because it's 10 to the right, or 10 across. Please do note that if the line was not starting from the origin, then it would have been much easier to do y2 minus y1 over x2 minus x1. Now, next part of the question says, calculate the distance traveled in the first 30 seconds. Now, another ground rule you need to know for speed time graphs is, whenever you're trying to find the distance in a speed time graph, all you have to do is take the area under the curve, or under the graph rather. We know that this is a graph, but if you look at the graph carefully, you can see that it's forming a trapezium looking shape. And if I were to find the area of this particular shape, or the area of the object, all I have to do is find the area under the graph. So basically find the area of all of this over here. However, this question asks me to calculate distance traveled in the first 30 seconds. So to calculate the distance in 30 seconds, let's go to 30 in our x-axis, that's there. Trace it to the graph, or to the point where it intercepts the graph, that's round about somewhere there. And we need to find the area of all of the parts over here, because it said only 30 seconds, not the whole 45 seconds. Now, as you can see, also this shape that we've created here looks like a trapezium. In order to find the area of this trapezium, we know that the formula we use is half into a plus b times h. So, substituting the values, we know this is going to be half into a. A is simply the value that's from here to here, which I think is 20. Yep, 30 minus 10, 20, plus the bottom, the value from the bottom, so that means from 0 to 30, that's 30, so plus 30, yep, and times it by the height, which I believe was 18, yep, it is 18. And then this is simply half times 50 times 18. Half times 50, that's 25, times 18 should be 450. Let's just confirm, 25 times 18. Yep, it's 450. 450. So our answer is 450 meters. The unit is there, but if it's not there, please make sure you include the unit. Now, the next part says, calculate the average speed for the entire 45 seconds. In my previous video about speed, distance and time, I stated that average speed is equal to total distance traveled or covered all over the total time spent, or total time taken. To calculate average speed, we need these two values. We have the total time, that's 45 seconds, because as you can see from the graph ends at 45 seconds, that's round about there, and even the question, part C, said that for the entire 45 seconds. So our total T is 45. But what's our total D? Total D, that's total distance. All that simply means is that we need to find the area under the whole curve. In the B part, we found the area under the curve for until 30 seconds, but now we have to do it for all of the 45. So all we have to do is, instead of finding only the area of this part here, we need to do it for all of this. So we need to not put a limit there and find all of this as well. So again, as you can see, this is another trapezium. Of course, the area of this is bound to be larger than the area of the previous one that we found, but let's see how it will go by the calculation. So we know that the formula is half into A plus B into H. This would be half times our A, which is, I think, 20. Yep, from here to here is 20, so that's 20 plus 45, because that's the bottom area, because that's where we ended. 45, yep, 45 here, and we times it by the height, which is 18. This is half times 65 times 18. So doing half times 65 times 18 in your calculator, you should get 585. So 585 meters. But that is not the final answer, because it did not ask us to find the total distance covered, it asked us to calculate the average speed. So now that we have our total distance, that's 585, what we have to do is put it back into this formula over here. So all this simply does is, we now know that average speed is nothing but 585 divided by 45. And 585 divided by 45 is 13. So the answer is 13 meters per second. Again, units was given here, but if not, please make sure that you put your units. And that is the final answer for this first example. On to the next example. Right, this one says an animal, let's zoom in a bit. Okay, that's better. Right, it says an animal starts from rest and accelerates to its top speed in 7 seconds. Okay, it continues at this speed for 9 seconds and then slows to a stop in a further 4 seconds. Okay, good to know. Now, all this piece of information, all this grammar, all it's doing is just explaining the graph in words. It said that an animal starts from rest, that's from here, and accelerates to its top speed in 7 seconds. So from here to here, it took him, or took her, the animal, took it 7 seconds. That's around about there. So 7 seconds to get to 14 meters per second. Then it says it continues at this speed for 9 seconds. So from here to here, it continues at that speed for 9 seconds. And then it slows down or decelerates to a stop in a further 4 seconds. So from here to here, it takes it 4 seconds to stop. So that's all it does. Now, the A part says calculate its acceleration during the first 7 seconds. So we know 7 is round about somewhere there, and they also told us that it reaches its top speed, that's 14 meters per second, in 7 seconds. So drawing a line from somewhere around about here and tracing all the way down, that's where 7 seconds is. Right, all we have to do now is find the acceleration, and all you can do for that is change in y over change in x. So this can be simply 14 divided by 7. So why 14? Because it goes 14 upwards, it ends at 14 here, and y7 because it goes 7 across. You could use y2 minus y1 over x2 minus x1, but that would take a lot of time, and time is of the essence during examination. So you can do this way, it's a quicker method. So 14 divided by 7, that's nothing but 2, and the answer is 2 meters per second squared. Units very important. On to the next part, the B part. It says write down its speed 18 seconds after the start. Okay, it says 18 seconds after the start. So the 18 seconds is here. So let's see where this intercepts the graph, and intercepts the graph somewhere here. And if you trace it back all the way to get the corresponding speed, this should be around about 6.5 meters per second. Or sorry, not 6.5, 7 meters per second. Why 7 meters per second? Because 1 unit one unit of the graph is 2, so from 6 it went to 8, so obviously the middle is 7, so 7 meters per second, not 6.5. Again, units very important. On to the next part, it says calculate the total distance that the animal traveled. Now, total distance the animal traveled simply means you find the area under the graph of all of this from here to here. And to do that, all we do is find the area of the shape. Again, this looks like a trapezium, and we know to find the area of a trapezium we use the formula half into a plus b times h. So half times a plus b. What's our a? Our a is 9, because from here to here is 9, because 16 minus 7, that would give you 9, so 9 plus, I think it's 20, it ends at 20 seconds, yes it does, 9 plus 20, and all of this times by the height, which is 14, because the question even stated that its top speed is 14 meters per second. So this becomes half times 29 times 14, and doing this in your calculator, half times 29 times 14, this is 203. So the answer is 203 meters. Again, units very important, and note that although the examples that we have been doing, the shape we are getting is a trapezium. We could have gotten a triangle, you could get any sort of shape really. And another method to do these sorts of questions is you can break down the shape. So rather than doing it as a trapezium, we know that, let's say a trapezium looks something like this. So let's say it looks something like this, goes from there, then you have a line going from here, another one here. Okay. Let's say this is the sort of shape you get in a graph and you are asked to find the distance traveled. So of course what you do is you find the area under the graph, but instead of using the trapezium formula, if you are not that comfortable with it, you can break the shape down into another shape. So suppose just break it down like this, boom, boom. So you now have two different triangles here, and you would have a square or a rectangle over here, and you can find the area of these shapes independently and then add them up all together at the end. That's another way of doing it. However, finding the area as a trapezium as a whole is much quicker. And onto the final example for this video, and this is a challenge question. So please do pause the video and have a go at this by yourself, and then resume the video to see if you are correct or incorrect. If you are incorrect, please take note of your mistake. Right, so what does this question say? It says, a small car accelerates from 0 meters per second to 40 meters per second in 6 seconds, and then travels at this constant speed. Okay, I think this is the small car, yeah, small car here. It goes from 0 to 40 in 6 seconds and then travels at the speed. It then says a large car accelerates from 0 to 40 in 10 seconds. Okay, from 0 here, the large car is here, from 0 to 40. Okay, good to know. It now says, question, calculate how much further the small car travels in the first 10 seconds. It says first 10 seconds, but the time ends at 10, so we're taking the graph as a whole. Now, it asks me to calculate how much further the small car travels. As soon as you see the word travels, you can pretty much estimate that, okay, they want us to find something to do with distance. And in a speed time graph, you find distance by finding area under the curve. But as you can see, there are two different curves there. You have a small car curve and you have the large car curve. And what this implies is simply that we need to find the area under the large car curve and then find the area under the small car curve, and then see the difference between the two, because it's asking us how much further the small car travels in the first 10 seconds. So let's find the large car first. Let's represent large car LC, large car. So the large car curve is the broken line curve, and as you can see, the shape it's forming is a triangle. We know to find the area of a triangle, since we're trying to find distance, we take the area under the graph, and the area of a triangle is nothing but height times base divided by 2, or half times half times height times base is the same thing. Our height in this case is 40, base is 10, divide this by 2, 40 times 10 is 400, so 400 divided by 2, this is 200. So the large car travels 200 meters in the first 10 seconds. Now let's have a look at the small car. Let's represent this with SC. SC, yes, okay. So the small car, as you can see, this is the curve from here to here and here to here. As you can see, this one is forming a trapezium. So let's do it. We know for a trapezium, the formula to find the area is half into A plus B into H. Half times A plus B, so A, that's from here to here, that should be 4, and plus B, that should be from here to here, that's 10, times the height, which is 40. So this becomes half times 7 times 40. Okay, not half times 7, sorry, it's half times 14. I already did the calculation in my head. Half times 14 is 7, so 7 times 40, and 7 times 40 should be 280 meters. And 280 meters is how much the small car travels. Now, again, the question says calculate how much further the small car travels. So your answer is simply the difference between 280 and 200, because the question asks how much further it travels, and we know that the large car travels 200, the small car travels 280, so obviously the small car travels 80 meters more than the large car, and your answer in the end is 80 meters. The unit is already there, but if it's not there, please make sure to include it. And that example brings us to the end of this video. Hopefully you enjoyed it, guys. Please do not forget to perform an LSS, that is like, share and subscribe. Also feel free to comment in the comment section below any questions or any corrections or any feedback you may have. And thank you for watching, guys. Have a nice one.